Hey guys, welcome back to Math Busters. Today we're going to be going over the properties of logarithms. Get some food, sit back and relax, and let's watch Aadit explain it.
Okay, so the first thing we want to understand before we begin is the concept known as the log rule. So right here, if we have log base a of b, and we set that equal to x, the log rule is essentially we can draw an arrow here and set a to the power of x equals b. And that simplifies a lot of things. Now, let's begin with our first property, which is the product rule. So in this property, we want to simplify the expression log base b of m to the n, and you want to convert that into some form of log base b, and then of m plus log base b of n. That is what this rule hopes to achieve. So we'll do that by saying, let's set some variables first. We set log base b of m equal to x. We set log base b of n equal to y. Then we can use what we know as the log rule. Right here, b to the power of y equals n. Right here, roll it over, b to the power of x equals m. When we substitute those in, we get this right here, log base b of b to the power of x times b to the power of y. Now, Akhil, what is the next step here?
We can just combine the exponents, right? B to the power of x times b to the power of y is equal to b to the power of x plus y.
Yes, and that is an exponent property, which is what we detail later. We'll get into that more later. So then once we do what Akhil said, we can have log base b of b to the power of x plus y, because this is a rule right here. If we have an same base, we can just add these two together. Now, what we'll do is we're given this, and then we can use the log rule because we defined that earlier. We know that if we have log base b of b to the power of x, and we want that to equal something, we can say b to the power of that something has to equal b to the power of x. We know that something is x. So with that knowledge over here, we know that b to the power of something has to equal x plus y over here, like that. B to the power of something equals b to the power of x plus y. We know that something is x plus y, and then we plug in what we defined right here as log base b of m equals x, log base b of n equals y, and we get this, log base b of m plus log base b of n, which is exactly what the product rule hoped to achieve over here. Cool. Now we will get into our next property. The next property is the quotient rule. So Akhil, given what we did with the multiplication rule, what do you think this expression right here would simplify to under the quotient rule?
I'd assume it'd be equal to log base b of m minus log base b of n, right?
Yeah, that is correct, but we will explain how to derive that. So similar to the last question, we want to set m and n equal to clever powers that have bases of b, because we can use the log rule because we have a base of b right here, and we can, with the same base, makes the log rule a lot easier to determine what the unknown value is. So we set m equal to b to the power of x. That assumes right here through the reverse log rule, we see b to the power of x equals m, and we set n equals b to the power of y, perform the reverse log rule, b to the power of y equals n. So what we can do is we plug those in. Now, Akhil, what would we do in this scenario?
Well, we can just set it to b to the power of x times b to the power of minus y, which is equal to b to the power of x minus y, right?
Yes, that is correct. This expression right here is another exponent rule. We have that detailed right here. If you have b to the power of x over b to the power of y, that equals b to the power of x minus y. Similarly, if we have b to the power of x times b to the power of y, this is simply b to the power of x plus y. That is the rule we talked about earlier. So we know that this is an exponent rule. We put that in. Again, we get the same question of the log rule. We know that this, we're looking right here, b to the power of what unknown equals b to the power of x minus y. And that unknown is x minus y. So we know what we defined x over here, we defined y over here. We simply plug those in and we get the final expression. So this tells you that log base b of m over n over here equals log base b of m minus log base b of n. Now we will get into the last property. Akhil, what do you think the last property is? It is the most common one.
Is it like log base b of m to the power of n equals n log base b of m?
Yes, that is what we call the power rule. So over here, we have this expression right here, log base b of m to the power of p. And we want this to be in the form of p log base b of m, right? This is what we are trying to achieve. And we can do this by setting m equal to, again, the base, with the base of, in terms of base b. Because we can then use the log rule and figure out what this unknown is, which will help us simplify. So using clever powers of base to the b, we figure out, we know the reverse log rule, that this is log base b of m equals x, because b to the x equals m. So what we will do here is we will plug in, we know what m is since we defined it right here. So we plug in b to the x, log base b of b to the x to the power of p. Now, what we will do here is, we know this is another exponent property, where if you're given like log base b, and then x to the power of 3, and then that to the power of p, this is the same thing. You can multiply these two exponents. And that is another exponent rule. And with that knowledge here, we can simply multiply the x and the p to get log base b of b to the x times p. Now, Akhil, what would be the next step?
You could just multiply them, right? So b to the power of xp.
Not necessarily. We would actually use the reverse log rule, because we know that this has to equal something. So we figure out, okay, b to the power of what unknown equals b to the power of xp. That is xp. And we already know what x is since we defined that over here. Log base b of m equals x. So we plug that back in, log base b of m times the p, and that gets you, move the p to the front, and that is p times log base p of m, which is what we proved right here. And now we will get into the applications. So simply knowing what the rule is and how to derive it isn't enough, because we need to know how to apply it as well. So the first question we're going to look at is right here. ln, in parentheses, a to the 3 over 2 times 4 to the power of 4x to the power of 3. So, Akhil, how would we simplify this?
You could just multiply the a to the power of 3/2 by 4x and then multiply that by 3, which would get you a to the power of 6x times 3, or a to the power of 18, and move that to the front. So it's 18x ln a.
Yeah, that is the easier way to do it, but because this is more of a conceptual video, I'm going to go over the more brute force method, which is, then we'll get into the easier one later. So what we can do first is, since we essentially proved that log base b of m to the p equals p times log base b of m, we can simply move this over to the front, this 3. That's what we do right here. But then again, we know, oh look, this is that p value that we defined right in that one power rule example. Simply move that over to the front. And since we're multiplying it, this is times the 3. Then 12x ln a to the power 2/3. We know, oh look, this is also the p value. So we can simply multiply that at the front and get our final answer of 18x times ln a. But again, remember, this is an exponent rule where if you have x to the power of p to the power of 3 to the power of 9, you can multiply these exponents together and get x equals 27p. This is an exponent rule. So similarly, we can multiply these exponents together, which is what Akhil is talking about. Then we get ln a to the 18x. And then we know, look, this is the p value right here, it's 18x. So we just move that to the front, and that is the easier way of getting this expression here. The second problem is something a little bit different. If you had watched our video on integration, then this will be no problem. But if you end up struggling on this problem, don't forget to refer to our integration video, which is very helpful in understanding the basics of integration. So with that, let's look at our second problem. We have the integral from 0 to 1/3 of e to the power of 3x minus 2 plus ln of e to the x squared dx. So Akhil, what is the first step here?
You can multiply the exponent, so you'd get e to the power of 2x, take the logarithm of that just give you plus e to the power of 3x minus 2 plus 2x.
That is correct. So what Akhil did is, we will move this exponent. Look, this is the p value right here. So we will simply move this exponent over to the front. That is this term right here. Then again, we know ln to anything for the e to the x is another property. That is this property right here. ln e is simply 1, because do the reverse log rule, we get log e to what equals e. Log e to the raised to what equals e. And that is simply 1. So this would evaluate to 2 times 1 times x, which is simply 2x. So we'll do that. And another thing we will do to split this integral up, which if you watched our integration video on the basics of integration, we know that that an integral that has many complex terms like this term right here and this term right here, we can split it up. We can split it up to make it 2 separate integrals. We have the integral from 0 to 1/3 of e to the 3x minus 2, plus the integral of 0 to 1/3 of 2x dx. And this is simply makes it a lot easier. So if we find the integral of this expression right here, e to the 3x minus 2, that is 1/3 e to the 3x minus 2. And if we find the integral of this expression right here, that is x squared, because we can move the 2x down and minus subtract 1 here by the power rule. And we know from our integration video we then plug in 1/3 here. We then plug in 0 there, subtract those, then add those two, plugging in 1/3 here and plugging in 0 here. And if we do that, we get this, because we know if we plug in 1/3, we get 3 to the power times 1/3, 1 minus 2, negative 1, minus the 3 times 0 minus 2, which is negative 2, plus 1/3 squared, 1/9, minus 0 squared, which is 0. This is our final expression. If you forget integration, or if you have any struggles with integration, don't forget to watch our previous video on the fundamental theorem of calculus and the basics of integration. I hope you enjoyed, and we look forward to seeing you in the next episode.